So water bills are rising exponentially, and unfortunately, drought is occurring everywhere, putting a strain on our local water resources and processing centers, and sometimes resulting in outright, voluntary, or even straight out bans on outdoor water uses in the summer. On a positive note, though, saving water saves money and helps you achieve residential green building certification standards such as LEED for homes, National Green Building Standard, and the GHI Green Star Homes, improving your home water score. So please stick around and learn more about this new and updated EPA tool for designing outdoor water savings. Now, before we get started, a huge thanks to one of our sponsors, Ream. And speaking of water, we can also heat our water more sustainably to save energy and to decarbonize by taking energy right out of the air up to 400% efficiency through a heat pump water heater. Their new Proterra has a hybrid system like what I have, where in the event that you run out of water with the heat pump, it can switch over to electric resistance. Or they have their 120 volt, which is easy plug and play to replace energy wasting and potentially unhealthy risks of gas usage. So you can check out more about this technology and saving energy over at Green Home Institute, REAM HPWH. All right. Well, welcome everyone to Saving Water using the EPA's WaterSense Outdoor Water Budget Tool version 2.0. This session is brought to you by the Green Home Institute. The Green Home Institute is a nonprofit with a mission to empower people to make healthier and more sustainable choices in the renovation and construction of the places we live. This session is approved for multiple continuing education units, including, we got a little few too many here today, but just our water pillar actually for our certified green home professional designation. AIA Health, Welfare, and Safety may make it applicable to your state-based design or contractor license. And check out that 5-digit passive house code that should accumulate at the end. If you're here the entire CU hour, you'll see it printed on your certificate over at Gutenberg. Now, before we get into it, just a real quick reminder that when it comes to LEED residential certification under version 4 multifamily and single family version 4.1 available across the planet, the EPA outdoor water budget will be composed of the water efficiency WE total water use pathway. There is a prescriptive and a performance path to obtaining your water points in LEED, National Green Building Standard, many of the green rating systems. Um, for the prescriptive path, we're looking at water efficiency ratings on fixtures, Energy Star certified appliances, WaterSense certified fixtures, and the percentage of a turf of how much this landscape makes up in turf to native adaptive outdoor plantings. So in the prescriptive pathway in LEED, we're not looking at this water budget tool. We're not discussing it. It is not utilized. However, you can get a lot more water points in most cases using the performance pathway, which looks at a number of devices, like having multiple different types of devices in each bathroom, or multifamily having different devices at different flow rates in each unit. If you have some situations where you have very low flow, like toilets and some aerators that can get down very low, they don't even show up in the prescriptive pathway. In other cases, you might have affordable housing agencies who want to use higher flowing toilets, for example, at 1.6 per gallons. And again, there'd be no points there for those under the prescriptive pathway. And so it just makes more sense in general to utilize the performance path. And so if you're using the performance path, you are required to evaluate the outdoor water use. Even if you don't want anything to do with it, you are required to evaluate it utilizing the EPA Outdoor Water Sense Budget Tool, which we are going to be discussing here. Now, you can see here the points associated with the LEED pathways depending on how much water you can save and what reduction over the baseline, both including indoor and outdoor, which we'll get into the checklist a little bit later at the end. But you can just see your corresponding reductions to point savings in the total water use pathway. Now, a quick note for all of our friends outside of the United States and Canada, you will not be using the EPA tool, but instead you'll be using the USGBC's developed outdoor water use reduction calculator to evaluate your project. This is also the same as they use everywhere on the commercial rating system. With that being said, I don't want you to leave. I think there's many tips and tricks we're going to discuss today that are going to help you consider how to save water. And because this tool was basically designed off of EPA's tool, I think you'll find value in this session to help you understand how to more accurately, fill that one out. So with that, I am excited to hand it off to our speakers today. We will have Holly Cannon as well as Sarah Lavoie with the EPA. So Sarah, Holly, welcome, and please take it away.
There we go. Camera was lagging a bit. Apologize for that. But yeah, thank you for the introduction and thank you for having us on today. Actually, years ago, one of my colleagues presented here about the WaterSense Budget Tool version 1 and how it was incorporated into the WaterSense specification for homes version 1. But since then, EPA has revised the home specification to have an entirely different approach to home certifications. And we just
Sarah, let me interrupt you for just 1 second. Are folks seeing my slides, Brett?
Yeah, try it again, please. Yeah, you'll have to try it.
Yeah, sorry about that, Sarah.
Oh no, it's all good. Jump into the intro.
How about now?
We're seeing your just like PowerPoint normal view. Nah, there you go. Now it's presenter.
Okay. So
great.
Full screen slides, yes? Okay.
Yes. Yeah,
all
you're
right,
all
sorry.
good.
Yep. All right, go ahead.
No, you're totally fine. But anyways, since Homes version 1, like I said, EPA has revised the home specification to have just a different approach in general to home certifications. And then we just recently released a revised version 2 of the WaterSense Water Budget Tool. And that's what we're going to chat about today. I'll start by giving some background about the WaterSense Labeled Homes program and how it has evolved. And then I'll hand it over to Holly, who will provide a demonstration of the WaterSense Budget Tool version 2. And then Brett will hop back on at the end to discuss how the Water Budget Tool can be integrated with LEED for residential. All right. So the WaterSense specification for homes was first released in 2009, and it was the first national home certification for water efficiency. Version 1 included a very prescriptive set of criteria for homes that addressed both indoor and outdoor water use with many, many mandatory requirements. And one of these requirements included the use of the WaterSense Budget Tool version 1 for the landscape design. Version 2 of the specification became effective in 2022, and it allows more flexibility for builders, letting home certification organizations, or HCOs, set their own criteria to reach a 30% water efficiency goal overall. Under version 2, builders can make a lot of choices about how to reduce water use in their home designs. They can decide whether to focus more on reducing indoor water use or outdoor water use, depending on what is the most desired by the home buyers in the area and how their chosen HCO evaluates different types of water use. So as a result of revising the specification to allow for this flexibility and to work with existing HCO infrastructures, we've seen a ton of program growth since the transition to Program 2. Even in 2025, as the overall housing market has slowed, we saw an increase in home certifications compared to 2024. Our highest concentrations of labeled homes continue to be in the arid Southwest, like Arizona, California, and Nevada. And we expect demand for water efficient homes to continue to increase. And fun fact, Realtor.com named WaterSense labeled fixtures the fastest growing trend of 2025. So that's exciting. And then we also released a case study last year from the first community of WaterSense labeled homes in Seattle, which was built over a decade ago. The case study provides some data to show that WaterSense labeled homes continue to save water over time and that residents continue to be very satisfied with the water efficient features, which gives us another reason to believe that the program will continue to be here and really keep growing over time. And speaking of WaterSense labeled fixtures, version 2 of the specification includes just two mandatory requirements. A home must include WaterSense labeled plumbing fixtures, and they must be free of leaks. Beyond that, as I mentioned, the home also needs at least 30% more or needs to be at least 30% more water efficient than a typical home on the market. And version 2 of WaterSense home specification, specifically for landscaping, has no mandatory landscape or irrigation requirements. Instead, outdoor water use is addressed in each of the HCO's certification methods in their own unique ways. We really rely on the HCO's certification methods to evaluate a home's outdoor water use. Reductions in outdoor water use are, however, still very vital to meeting that 30% requirement. It isn't really possible for a builder to reduce indoor or to reach that 30% goal by reducing indoor water use alone to achieve the WaterSense label. Even though builders are not required to use the water budget tool anymore, it can still help them design a landscape and irrigation systems that are more water efficient. And to be extra clear, we didn't remove the requirement for using the water budget tool because the tool isn't effective. We did it to give builders more flexibility and to rely more on HCO's existing infrastructure to evaluate the home's overall water use. And then again, to achieve the 30% efficiency requirement, builders choose a WaterSense home verifier and an approach using one of WaterSense's 4 approved HCOs. Each HCO has a certification method, which EPA reviews and also approves for ensuring a home uses 30% less water compared to typical homes in a variety of climates and regions. For example, if a builder is using ResNet's HERS H2O method, they should look for a score of 70 or lower to ensure the home is 30% more efficient than typical homes in order to earn the WaterSense label. And similarly, there are maximum performance scores under the Cheers WaterSense method, Green Builders Coalition Water Efficiency Rating Score, and Home Innovations Water Rating Index. Home Innovation Research Labs also has a prescriptive method where a builder incorporates a specific practices with the National Green Building Standard to meet the 30% efficiency goal. Home verifiers are trained through individual HCOs and verify homes meet the HCO's methods, requirements, and performance thresholds. WaterSense oversees all these HCOs. We review any changes to their organization structure or certification method. And so, although HCOs effectively manage the certification and work directly with the home verifiers, EPA does have a fairly tight control on what the HCOs can and can't do. By approving these qualified organizations to utilize their existing certification process to certify and label homes for WaterSense, we are able to leverage an existing infrastructure. So, just to reiterate, the main point here is that although the water budget tool is no longer required under the specification for WaterSense labeled homes, we recently revised it to make it a more useful tool for builders, landscape designers, irrigation professionals, developers, really anyone who's looking to maybe budget for a landscape. Builders can use it to design water efficient landscapes or confirm designed landscapes will save water. And this should help them demonstrate reduced outdoor water use in their HCO certification method. And now I'll hand it over to Holly to talk specifically about the changes for the water budget tool version 2.
Awesome. Thanks, Sarah. And hi, everybody. Still see my screen? Everything's good? Tech check?
All good.
Yes.
You're
Okay,
good.
awesome. Did you have a question, Brett, or are we
Just
good to
letting you know
continue?
I could see your.
Okay, awesome. Thank you. So I'm Holly Cannon. I am with ERG. We are a contractor to the WaterSense program. We've been supporting them, and I've been supporting them since the program's inception in 2006. So it's been a really great, wild, long ride. I love to see that slide that Sarah showed about the growth of the homes program specifically. Being around for so long, it's really cool to see when you make a big specification change like that have such a profound impact on the number of labeled homes we're seeing, the amount of water we're saving. The program is just super great, super awesome. So thank you for being here to hear about it and hear about the water budget tool. So last year, late last year, my team helped EPA revise the water budget tool to include new data and assumptions that we have, and hopefully, like Sarah said, make it more usable for a variety of audiences now that it's not required by the specification anymore. I had originally like set this presentation up just to talk about the changes from version 1 of the water budget tool to version 2, but I realized some of you may not know what the water budget tool is at all. So I'm going to quickly cover the basics. And the bottom line really is that the tool is designed to help users improve water efficiency through landscape and irrigation design. So it's going to guide users to enter some basic project information, the most important information being the zip code where that landscape is located and the size of the landscape area. Those two things, more than anything else, are going to impact the total water use of your landscape. From there, the tool is going to calculate an estimated baseline water use for the landscape, and it's going to assume that you have a landscape entirely comprised of cool season turf grass and all watered with spray irrigation to replace the water loss from evapotranspiration or ET, which is the measure of the water that the plant needs. And it's assuming those two things because those are the two most, sorry, did that just rapidly change. It's assuming those two things because those are the most kind of water intensive options for a landscape. Cool season turf's going to require a lot of water. Spray irrigation is one of our less efficient distribution uniformities assumed in the tool. So it's giving you kind of the highest baseline that you could possibly have to compare your landscape to. Then the user is going to enter some information about the landscape that they want to design or modify. So that's going to be plant information, irrigation system information, and some other details. And then the tool will determine how much water that design landscape is going to save over the baseline and help the user understand if they met their predetermined water efficiency goal if they had one, or just help them understand, how is this landscape going to compare to a typical new construction landscape? What is it going to look like? How did I do in terms of design? So, Water Budget Tool version 2.0, we released in September 2025. And this gives you kind of just a gist of what we changed, kind of the big picture items, but both version 1 and 2 function roughly the same way. They're comparing that design landscape to the baseline landscape. And these changes we made to version 2 really improve and expand the tool from version 1. So for those familiar with version 1, I'll cover those basic changes when I demonstrate the tool here in a minute. It's probably going to make even more sense once you see it visually. But first off, I'd say the biggest revision to the tool is we wanted to expand our water use estimates from just peak month to estimating water use over an entire year. And to do that, we decided to add some data to refine the tool and make it even better. And one of those things is we define growing season by zip code, and we incorporated that growing season data into our net ET calculations. And I'll show you as I walk through the tool how that works. We also included a really important assumption that acknowledges that irrigation system operators typically are not operating or not irrigating to the full water plant demand that a landscape would require or need. So as such, we incorporated an irrigation application rate percent to more accurately predict outdoor water use based on what we're seeing in the field. And again, I'll talk through that and show you the resource we use for that. Similarly, we wanted to give folks credit for water savings we estimate or see in the field for things like using irrigation professionals certified by a WaterSense labeled program to design and install irrigation systems, choosing WaterSense labeled irrigation controllers, and using WaterSense labeled spray sprinkler bodies. These are super great choices. They're going to save you water, and we really wanted that to be prominent in our tool update. We also got feedback over the years that folks wanted to account for more zones when designing a system. So we added a lot of rows to account for many more zones, and we now believe the tool can even be used for commercial landscapes. Of course, as always, we'll sometimes get requests from our helpline to say, I need even more zones, and we're still willing to take those requests and add more and make the tool usable for any size landscape. But hopefully what's now out on the website can be pretty broadly applicable no matter what your landscape size is. The presentation doesn't like when I stay on one slide too long, so sorry everybody. Talking through all this. Let's see. Users can also now select their own outdoor water use reduction goal instead of striving for the 30% required in the Water Budget Tool version 1. So as such, the tool is no longer like a pass or fail. It's really just, you can put in if you have a specific reduction goal that you're targeting for, you can put that in. It'll tell you how you're doing. If you don't have a goal, it'll just kind of estimate what your design landscape is, and you can compare that to your baseline on your own. We streamline inputs and reports. We added a neat graph at the end to show how your baseline landscape compares to your design landscape to give you a visual. And of course, we scrubbed any references in the tool to this tool now being required by the WaterSense specification because it is not anymore. So how can the tool be used? I put some ways here. Although it's not required under the home specification, we think that builders and others can use it to help design a water efficient landscape and irrigation system when they're planning new construction. And, if you it may be more commonly used to look at an already designed landscape and say, okay, I've designed this landscape. How's it going to do? They can use it to evaluate potential water use and savings from that already designed landscape. And they can hopefully use it to meet that 30% efficiency requirement in the home spec that Sarah talked about. That's really going to depend on the HCO that the builder chooses and their certification method and how they account for outdoor water use. But we do think using the tool and seeing some outdoor savings certainly won't hurt your score, regardless of what HCO and certification method you use. It can also help evaluate how landscape transformations or irrigation system retrofits and redesigns may behave, how that may impact your water use of an existing landscape. It could be used to determine if a home or commercial property may meet a specific water budget or a water use reduction goal. Maybe that's issued by a municipality or a utility or an HOA, or maybe a builder or a property manager is just striving for something in particular. And then this last thing, we have not fully tested and vetted this yet, but one of the scenarios I'm going to talk through today shows that, and I've also heard this anecdotally actually, the tool can be used potentially in some cases to compare actual meter data to these theoretical water use estimates for design landscapes. And that can kind of give you a little information on how your system is operating, how it's behaving. We'll talk through more about this is not the main use case, and I'm not saying everybody should go out and look at their water meter data and compare it. There are certainly caveats here, but that is one scenario that we'll talk through. And then Brett, as Sarah mentioned, we'll talk later about the lead correspondence. So without further ado, let me just stop sharing this so I can pull the tool up. And Brett, you can tell me if I'm doing this right once I get it going here. Okay, awesome. And are there any questions you want
We'll get
me
to,
to
you can keep
address?
on, just go ahead.
Okay.
Yep.
Okay, cool. Okay, so here's the water budget tool. If for those familiar with version 1, it looks quite a bit different. We have 4 main tabs of inputs and some references and equations and data. But this step 1 page really just kind of gives you some background. It talks through what our color coding means. Only green is required information. Yellow is sort of optional depending on your use case. White is going to auto-populate, and then any blue coloring is really just formatting, so that's kind of ornamental. And this tab tells you, what is each tab for? What do they do? What date was this updated? It provides you the link. It's kind of our baseline information tab. And what I'm going to do is walk through, I'm going to start here and walk through I have three scenarios I want to walk through today, but I'll walk through the first one and then I'll talk to you about the background equations. So you can first see how it operates. We'll go through the equations and then we'll do two more quick scenarios. Hopefully we have time for that. So my first scenario here is, and in an ideal world, you'd fill all this out, but we're not going to do that. It's my Utah new build, and all of my examples are single family. Brett, right before this, was like, "Hey, do you have a commercial scenario?" And I don't, but he does. So good news there. So we're going to work through some single family scenarios here, but first, I want to talk about in this hypothetical scenario, I'm going to build a water efficient landscape and irrigation system that's going to reduce water use by at least 30%. So here's where I can put in my goal. So I'm looking at for 30%. And I am in South Jordan, Utah, where there's a lot of new construction. South Jordan, Utah also has a lot of outdoor or several outdoor requirements in their local municipal code. So when I'm using this tool, I want to make sure I'm incorporating those requirements that they have. So I'll go ahead and put in my South Jordan zip code, which is 84009. And my landscape is going to be about 3,100 square feet. It's a 0.1 acre lot, which is about 4,400 square feet. I'm going to subtract out the house footprint, and the driveway and that sort of thing. So we're coming in at about 3,100 square feet of landscape area that I'm going to be working with here. So I put that information in. My baseline tab is going to auto-populate for me based on that information I put in. But if you see here, I have some errors. So it's showing no data. I know something's wrong. So I see this red please note, and I'm like, okay, I should read that. That looks important. If no data is shown for rainfall and ET for the provided zip code, input a nearby zip code instead on the intro tab. So what happened here is, we have a lot of zip codes. I don't know the exact number, but many. But for some of these new construction communities, that zip code is just too new to be in the tool. So what I did instead is this zip code is for sort of the western side of South Jordan. I looked over at the eastern, central, more developed sides, and I'm going to plug in their zip code because I think it's close enough. And that's going to help me still get the right plant ET and rainfall and all that. Okay, so I'm all good there. I've corrected that zip code. All this data is being pulled in. It's pulling in again, white means I don't have to do anything. So it's all auto calculating. It's pulling in the landscape area I said, and then it's calculating all this information. And so what this is doing here is it's pulling in my monthly rainfall in inches for that zip code. And then we are calculating what the effective rainfall is. That's the rainfall that we believe is going to actually be usable by the landscape. And we're assuming that it's 25% of the monthly rainfall. That's a kind of baseline conservative estimate that WaterSense uses for effective rainfall. Then it's pulling in my monthly ET. And I'll talk about what these sources are once we review the reference equations and data. And then it's calculating my mod net ET. So my mod net ET is going to be my monthly ET minus my effective rainfall. That's what my plant is going to need. So my plant needs its ET replaced, but if we're getting enough rainfall, in fact, if we're getting more rainfall than ET, this mod net ET may show up as a zero. It's going to say rainfall's got you. You don't need to add anything else to this landscape. It's also going to show up as zero here if you are outside of the growing season. And this is a major new change that we added. So again, I'll talk through on the reference equations and data tab how we got there. But up here, you'll see that for South Jordan, Utah, my growing season is April to October. So any month that is not in those months is going to show up as a zero. My theoretical irrigation requirement baseline is going to populate here, and I'll talk about that equation again on the reference equations and data. And then my outdoor water use baseline. So the outdoor water use baseline is calculated based on that TIR, but it's applying that irrigation application rate percentage that I talked to you about. So, and we have this information up here. So based on information from the residential end uses of water study, we are acknowledging that operators are not irrigating landscapes to their full plant water demand. That study indicated that users are actually putting about 58% of the baseline theoretical irrigation requirement on the landscape. So we're applying that application rate of 58% to that baseline. So we're assuming this is actually what the user is going to do. Okay, that's your outdoor water use baseline. Now, you can adjust that if you know that you're applying more than, and one of my scenarios, we'll talk about this, kind of keeping up with the Joneses next door. They got a really green yard. I'm applying more than maybe I want to or would. If you have a better number for this, we're allowing you to override. We've also anecdotally heard that commercial landscapes, commercial system operators typically apply more to 100% of the plant demand. So if you have a commercial landscape, or multifamily, maybe you might want to set that in there and assume your baseline is higher than what we're assuming with this 58%. Um, Let me see if I have anything else on this slide. I think that's it. Okay. So this is our baseline. It's all calculating. We're going to go over to our design scenario. Um, so let me explain. So South Jordan, Utah, again, has these outdoor landscaping requirements. They're for front and side yards. It's in their subdivision and development code section of its municipal code. The city recommends and encourages that you use these same requirements outside in the backyards. And so the scenario I'm going through today is assuming that this builder is going to incorporate all of this everywhere, which is kind of a best case. So they require drip irrigation with pressure regulation unless it's a turf area. They require turf and plant beds are irrigated on separate valves and zones. They require WaterSense irrigation controllers with a rain delay shutoff, and they require that no more than the greater of 250 square feet or 35% is turf. So here's my tool. I'm gonna come back to this section about these system-wide savings potentials. I'm gonna go down and start inputting the zones that I'm working with here. So I have zone one. That's gonna be my turf. I have zone two, which is going to be my entertainment space. I didn't already separate out my patio from that 3,100. So I'm going to do that here in that entertainment space. Zone three is our plant beds. And that's it. Those are the three zones I'm assuming in this new build. So the turf area, that can be up to 35%. So I'm going to go ahead and just do the maximum I can do there. So 1,085 square feet of turf. I'm assuming this is cool season turf grass because I am in Utah. So here are the landscape types I have to choose from. Warm season turf, that's typically in the south. Cool season turf, non-turf plants, non-irrigated ground, which we'll talk about in our zone two. Xeriscaping, which is really only for kind of a desert climate, and then a vegetable garden. So this is going to be cool season turf. I'm going to use spray irrigation. And then I'm going to go to my entertainment space. So I have a pretty standard patio. I have a 200 square foot patio. This is non-irrigated ground. And as soon as I select that, it's applying no, it's not estimating any irrigation use for that. I could go ahead here and select no irrigation, but it's already kind of done that for me. And then we have our plant beds. So let's see, I had 3,100 square feet. So I have maybe 1,800 square feet of plant beds. And you'll see these errors popping up over here asking me to do something. So, I need to enter this information. This is all calculating out what my theoretical irrigation requirement is for this efficient landscape by month. And it's basing it really on this landscape type and on the irrigation equipment that I'm selecting. So here I have non-turf plants. And because South Jordan requires it, I'm going to select micro irrigation. And we are now assuming that all micro irrigation has pressure compensation. So this column is going to give you credit for pressure compensation, specifically in the spray, and I think also the rotor scenario. For micro irrigation, we can say yes, but it's already applied it, so it's not going to change my water use estimate. You can see it for spray irrigation. If I decided I'm going to install WaterSense labeled spray sprinkler bodies and improve that pressure regulation, if I said yes there, it's changing my water use over here and giving me credit for that. But for this scenario, I'm not going to include that. So I've got my zones in. I'm going to scroll down. Now, remember, we added a bunch of rows for zones. So this is like a long scroll here. But we're going down, and first I want to check, are there any warnings? And there is a warning. So it's telling me the combined area of the landscape is less than the total landscape I put in. So I haven't accounted for something. And it is because I just kind of estimated this 1,800 square feet here. So let me go and actually make that right. Okay, so now I've fixed everything. All my landscape areas accounted for. It's showing me my monthly potential water use for this design landscape, showing me my annual use. So now I want to go see, I needed that, or I was looking for that 30% reduction. So let me go see how I did. Okay, so I am at 27.5%. And this is your summary of results. So I mentioned that we expanded this tool to account for annual water use, which is all here, but we still did keep that peak month um, display. So this outdoor water use baseline is what that baseline landscape is estimated to use. This outdoor water use for the water efficient landscape design is for my design landscape. And then this percent reduction is showing you how much I'm saving from those two scenarios, so from my baseline to my design scenario. And I put my goal in, so it's going to give me a yes or no if I met the goal. If I didn't, this would just be nothing. And we'll show that later in another scenario. So anyway, I'm not quite at 30%, but now I'm actually remembering that South Jordan, Utah requires that WaterSense labeled irrigation controller. So I told you I was going to come back to that, and I am. So up here, I mentioned previously that we wanted to make sure folks are getting credit for these great choices they're making using WaterSense labeled products, WaterSense irrigation professional certified by a WaterSense labeled program. So what's happening in this first section is if I choose a WaterSense labeled weather-based irrigation controller, soil moisture sensor, or if I have a rain sensor installed, it's going to apply savings to every month in every zone for those choices. And these are not additive. So if you have one of them, it's going to give, if you have multiple of them, it's only going to give you the savings from the higher um, percent savings potential selection. So they required I have a WaterSense labeled irrigation controller. I put yes there. I have a weather-based one. I don't have a soil moisture sensor, so I'll say no. But did you see here when I change from yes to no? It's this water savings is happening. It's all being applied here in these monthly calculations. So you can see the change. And then it did require a rain sensor. So I'm going to say yes, but as you'll see, nothing changed because I already have my 15% savings from my weather-based irrigation controller. They did not require that I design or audit my system using an irrigation professional certified by a WaterSense labeled program. So I'll say no. But if you do choose that, it is going to give you a 5% savings. So it's another really great choice. So I've plugged those in. Let me go back to my results summary. Okay, so good news. I've met my 30% goal. It seems like South Jordan, Utah's, landscape code does seem to help design a water efficient landscape. But remember, I incorporated this throughout the whole yard, not just the front and side yards. So that hopefully will help me if I'm looking for WaterSense certification through my HCO. Hopefully this landscape design will give me some credit and help me get there. Um, okay, so that is that first scenario. Now let me walk you quickly through, and I'll make this a little bigger so folks can see it. I'll walk you through these reference equations and data, and then I'll take a short pause, Brett, if questions are coming in before I run through the next two scenarios. So, reference equations and data, this is telling you kind of everything we have going on in the background. Most of this information is from the WaterSense Technical Evaluation for Approving Home Certification Methods document. You can find that document here at this link. That gives you tons of equations we're using here, assumptions, data, sort of all the rationale for how we built this tool. We built this tool for, the general user, but we use a lot of these same principles when we're evaluating our HCOs and determining if their certification methods are going to reduce water use by 30%. So that's sort of the basis for everything we got. Our reference ET and rainfall, we're using the same sources we used in version 1. It's a International Water Management Institute's World Water and Climate Atlas, and that has an average monthly ET, maybe even be daily, from 1961 to 1990. So it's a little bit dated, but we've looked for a better source, and we really feel like this one just provides the best consistent national coverage for estimating these climate parameters. And we've processed that and provided all the data here at the zip code level. So this is both reference ET and rainfall from that same data set. So then we established the growing season, which we felt was really important because when you start looking at annual water use, it may look like you have an ET need in December in Boston because the plant need is outweighing the precipitation potentially. But we know that nobody's irrigating in Boston in December because it's cold and it's your system's going to freeze. So, and you don't need that. So instead, we wanted to establish the growing season and make sure we were being more realistic. So we use data from NOAA, the National Oceanic and Atmospheric Administration. We use their daily climate normals from 1991 to 2020. And we calculated growing degree day using the temperature minimum, daily temperature minimum, and temperature maximum. And we subtracted a baseline temperature. This is a pretty standard equation for growing degree day or GRDD. And then we assumed that in any month that has, okay, so sorry. So you're going to calculate the GRDD, and if it is positive, that is a growing degree day. So if your average temperature is greater than the baseline plant temperature of 50, that's a growing degree day. If it is negative, it's not a growing degree day, it's just zero. So what we did was we assumed that any month with more than 50% positive growing degree days, that was part of the growing season. So if I'm in April and I have 10 positive growing degree days out of the 30 days, that will not be part of the growing season. I'm not assuming irrigation in that month. However, if I have 20 positive growing degree days out of 30, then that will be probably the beginning of my growing season. So that's how we did that. This pulls in all of your information automatically when you populate your zip code. And there's, data behind the scenes that's all being pulled in here, but it tells you your monthly rainfall, your monthly ET, your growing season. And then here are our calculations. So the ModNet ET, again, is that monthly ET minus the effective rainfall. We talked about that. And then your theoretical irrigation requirement is using a conversion factor, taking that ModNet ET, and then also adding in information about each of your zones. So how efficient is your irrigation system? What's the DU of the irrigation system you chose? What's the landscape coefficient species for the plants that you planted? Kind of summing all that up and giving you that theoretical irrigation requirement. And I'll show those values here below. And then the baseline is going to take that theoretical irrigation requirement and it's going to apply that irrigation application factor, irrigation application rate percentage of 58% in our assumed scenario. We're leaving that 58% default because that's what the residential end uses of water use study told us is happening in the field. Again, you can override that if you have something better to use. And then the design scenario is doing the same thing. It's still applying that 58%. It's using your more efficient, potentially, landscape and irrigation system, and it's going to add it up in a similar way. So here are our species coefficient. We've streamlined these selections a little bit from version 1 to kind of bucket things a little more. And then same with our irrigation parameters. So you really only have a few choices here for your irrigation type. And then there's all those savings that apply system-wide. Here are all of our assumptions there and what the percentage that we're assuming. You can go look at our background if you want to. And here are a couple of other, that conversion rate and the irrigation application factor. We gave that, that resource here as well. So that's the gist of it. Brett, if you want me to pause to take questions, I can do that, or I can keep running through my other two single family scenarios.
Yeah, I think the clarification was you had mentioned something about multifamily or commercial projects changing a number. Can you just clarify that one again?
Yes. So that is this application rate percentage. So the data we're using from that is from the residential end
Oh,
uses of water study. So it's a residential
yeah.
assumption. They're assuming that, or somehow, through their analysis, determined that operators of a residential irrigation system are applying about 58% of the actual landscape water need. Now, we don't have any data for a commercial landscape, so we're assuming 58% across the board. However, we had some peer review of this before we released it, and anecdotally, somebody said commercial property owners are actually applying more to 100% of the landscape water need. So that 58% may be ratcheting down that baseline a little too much. So
I see.
you can right here, and I'll show it in my
Yeah.
next scenario, override, and that will give
Yeah.
you a higher baseline, and it's also going to assume you're using more water in your design landscape.
Okay. Yeah, and I'm glad you reminded me of the end water use because I know we had them on when they had the last report come out several years ago. I think the next one is due this summer. We're going to have them on again. Would that then, when that comes out, would that then necessitate a version change on this if they have new data?
Potentially, yeah. I haven't seen even preliminary results from that yet. I
Right.
think my colleagues at WaterSense maybe are more in tune with that, but
Yeah.
potentially, yeah.
Yeah.
Um,
All right.
so
Well, that
so
was
yeah,
it. Yeah. So continue on.
cool. Okay, so I'm using the same tool and this is real time. So I got to delete out my Utah scenario. I think I only have to remove that. And then over here. Okay, so we're back here. So my next scenario is I have a home in Augusta, Georgia, and it is not brand new construction. So it's been around a little bit of time, but the homeowner, now want to I want to change my landscape. It's sort of a standard build, mostly turf, a little bit of plants kind of just around the you know, perimeter of the home of like right near the house. But I want to add some curb appeal and I want to add some entertainment space. I got on the COVID vegetable garden bandwagon and now I want a huge vegetable garden. So I want to change the landscape I have. So this is our, let's see, property name, we'll call this our Georgia redesign. And I'm just wondering when I make all these changes, how much, how is my water use going to be impacted? So that's what I'm using here. So I'm in Augusta, which is 30809, and I have a point 0.3 acre lot, so a little bit bigger than Utah. Again, not brand new construction. I have about 10,000 square feet of landscape that I could potentially irrigate, and that's subtracting the home footprint, the driveway, the walkways, and a small patio that I already have. Okay, I have no goal, so I don't have to populate anything there. And let's go over here, make sure I have no errors. It's looking good. It pulled in my zip code. So I can see that my annual outdoor water use baseline is that 145,000 gallons. Although, so this is my keeping up with the Joneses scenario. So my neighbors their grass is green. So I'm not going to skimp on water use here because I want to look as nice as they do. So I'm actually going to up this to 80%. It's a little bit arbitrary of an assumption, but I'm just assuming I'm applying more than the average user, okay? Because I'm really trying to look good in the neighborhood. So that'll give me a higher water use baseline here, and it's also going to assume that I'm going to apply more water in my design scenario. So I'm over in my design scenario, and I'm just going to go into it here. We'll again go back to the top. So I have zone 1, which is the plant beds near the house. Zone 2 is my turf. It's just a really small plant area, and the rest of my landscape is turf. Um, and so this is non-turf plants. I'm going to assume it's all spray irrigation, no pressure regulation. So this is I'm actually putting in zoysia grass. So it's a warm season turf. That's pretty standard here in Georgia. And I'm applying spray irrigation to that. And Georgia does require a rain sensor. So I do have a rain sensor installed. So I'm going to say yes to that. And these don't have to be input. If you put nothing up here, these are going to assume no's. So I'm saying yes. I'm not putting anything else. All right. Let me scroll down. All right, I'm looking good. So I'm going to go over here. So it already looks like I'm saving a lot of water, and that's because my baseline scenario is assuming cool season turf grass across the board. Um, we haven't yet applied any type of, line where we're assuming warm season instead of cool season. It is possible that somebody's going to put in a tall fescue. I don't know. So compared to typical new construction with that cool season turf grass, I'm already looking pretty good. But, my goal here is not to save the 30%. I'm doing a redesign. I just want to see how my water use is going to be impacted. So this doesn't really matter to me. I'm just kind of looking to compare to this 141,000 gallon number. That's what it's telling me I'm likely using on my current landscape. Okay, so we're going to remember that number. All right, so I'm now going to remodel. So I'm going back to my design scenario. And what I want to do is I already told you I'm adding curb appeal, so I'm gonna increase my plant beds near the house quite a bit. I'm gonna double that. So that's around the house, that's near my mailbox. I'm just adding more plantings, I'm making it pretty. And then I'm gonna skip turf for a second. I'm gonna go to zone three, which is entertainment space. And that's a big fire pit. So I already have a small patio. I'm expanding it a ton. I'm adding 300 square feet. I'm gonna have my friends over. It's gonna be great. And then zone four is gonna be my veggie garden. And that's also pretty large because I have a family. So I'm still I have so let's go back to my landscape type and irrigation equipment here. The plants are still non-turf plants, but I'm actually going to irrigate them now with drip because I'm doing a full redesign. I have somebody helping me make this nice. I'm going to save water. So now my turf. Okay, so all of these changes that I made reduced the turf. It all took away from my turf. So I need to adjust this down to think I'm at 8,200 square feet. So I've removed some turf area, still warm season turf, still have spray irrigation. I am going to add some spray sprinkler, WaterSense labeled spray sprinkler bodies, because again, I'm going for full improvement. My entertainment space is non-irrigated ground, and that has no irrigation. And then I have my vegetable garden, and that I'm also going to irrigate with drip. Okay, let's see. And then I'm also, again, I said, I'm really going all the bells and whistles. So I'm going to have a WaterSense labeled irrigation controller, and I am going to have a certified pro help me with this whole project. So I'm going to add that savings on as well. So let me go down. Okay, I got all the landscape area, and we'll go back over here. Okay, so I'm at 94,000 gallons now. We were remembering the number 141,000 gallons. So I've reduced my water use by about 30% from my original landscape, and about 50% from the typical new construction. So I'm looking pretty good. Again, I mentioned these graphs that can kind of show me how I'm doing. So yeah, that's my design scenario option.
And on those certified landscapers, I assume that's really for irrigation assistance. You're not necessarily hiring one to actually do drought tolerant landscape design. It's really more on the irrigation side, or a little bit of both.
Yeah, maybe Sarah is probably the better person to speak to this because I don't work on that pros program as much as her. But Sarah, correct me if I'm wrong. We have certified pros for irrigation system design, installation, auditing. I don't think we have landscape design professionals right now. Sarah, hop in if I'm incorrect.
With my mic.
Well, we
And
Sorry, I
can.
was having a hard time with my mic there. Yes, Holly is correct. Currently, our certified professionals only work in irrigation. We're exploring perhaps landscaping, but that would be way, way, way down the line. So yeah,
mhm,
that's where we're at right now.
Okay, thank.
thanks, Sarah.
Hmm.
Anything else, Brett?
Nope, go ahead. Nope.
Okay. All right. So my last scenario here I mentioned is comparing my friend's water bill. And I want to reiterate, this is like very new and may not always work. So this is just one scenario where I did this because I was preparing for this presentation and I said, I want to see how this is actually can it predict, potentially actual water use. So okay, zeroing things out here. So this is my friend. She lives just outside of Denver. So we have our Denver water bill comparison. And she does not have a separate irrigation meter. So what I had to do was take her water bills, look at what I would consider an indoor baseline in the winter, so December, January, calculate out what I would then assume the indoor water use to be of that baseline, and then back out what the outdoor water use would be given her annual water use. So it ended up being about 50-50, 50% indoors, 50% outdoors. Um, so she is in Denver. Let's see. Oh, I hope I remember her number. I might actually have to Google it because I don't think I have it written down. Give me one second here. Um, So this is her zip code here in the suburbs of Denver, and she has about 2,000 square feet of landscape. This did not like 800. Okay, hold on one second. Here we go. So here we are, we're in Denver. She's watering from May to September, which she said was fairly accurate. Um, I got her landscape area plugged in. I'm assuming she's the typical user. I think she's probably irrigating to what reuse estimated she would be. So let's go to her design scenario. She does not have an irrigation, WaterSense labeled irrigation controller or a rain sensor. They are, um, this is one of my friends, so she's an environmental scientist as well. So she is paying attention to weather and turning her system off when it rains, but she does not have a rain sensor installed. So, and no irrigation pro. So let's look at her zone. So she has turf. She has a pretty sizable veggie garden. And then she also has a zone where um, it's landscaped but not irrigated. She said it's mostly just kind of mulched over. It's an area they're not really using. And I did want to show how the tool can account for that. So her turf is about 1,500 square feet, and that's cool season turf with spray irrigation. Her veggie garden is about 200 square feet, and that is non-vegetable garden, yes. And she does have drip there. And then she has about 300 square feet that is landscaped but not irrigated. So I can put in non-turf plants and then I can select no irrigation because she's not applying water there. Okay. Um, so we have no errors. We'll go over here. Okay, so her baseline is 26,000 gallons, 27,000 gallons-ish. Based on the landscape I put in for her, the water budget tool estimates she uses about 21,900-ish gallons. And based on her water bill, she was using 22,500 gallons. So this is within 5 to 600,000 gallons. Now, again, this entire tool is an estimate based on many assumptions and equations. It is not going to perfectly predict outdoor water use by any means. So when I got this number, I was like, whoa, that's pretty cool. I kind of looked back at what was going on in Denver in 2025, which is the year that this data was for. They started out with a pretty dry summer and then it ended up being pretty wet in the end. Overall, it was about average precip for them. So it's possible that because it was a pretty quote unquote normal year, her water use was fairly spot on to what this tool is going to predict. Now, if it had been a super dry summer and she was irrigating significantly more than this would say, that would be totally normal and expected. So if you do want to use the tool in this way, you really just need to be thinking about what's going on in that area, what's going on with that climate, what type of irrigation operator am I? Am I paying attention to weather? Am I adjusting my schedule? It kind of helps you raise those questions and think about your water use and how it may compare rather than predicting exactly what you're going to use. And then one more thing, I just wanted to mention that this tool is not meant to predict or help with irrigation scheduling at all. So it is giving you that monthly estimate, but users shouldn't be going in and saying, okay, in May, I should probably use 3,600 gallons of water. That you really need to be using local weather data, real-time weather data, and scheduling based on that information, not what this tool is putting out. So. Yeah, so that's it. I'll hand it over to you, Brett, or I can take more
Eh,
questions if
Well,
we have them.
and somebody, one of our, guests pointed out that the GDD, which was cool, I hadn't heard of growing degree days, was similar to
Mhm.
CDD, cooling degree days, in the same way we use for HVAC calc. So then
Right.
would you say in a similar sense that if, you know, we do energy modeling, right? And there may be diversions, hotter or cooler one day, so it's diverting from the model. So would you say in this sense, same logic here, that you would just look, are your GDDs different than what this is saying, and that it might explain a deviation?
Absolutely.
Yeah.
Yes. Yeah.
Okay.
So yeah, if you're spot on, you want to think, okay, does that make sense? Am I kind of the typical user? All right. If you're way off one way or the other, you got to think through why that may be.
Yeah.
And maybe you're under irrigating and your landscape still looks good and you're happy with that. And you're like, look at me
Yeah.
saving more water. Great. If you're vastly over, that's when you really want to question, could I save more? Um,
Mhm.
is there a dry year going on? What's going on? Why would I be putting so much more water on the landscape?
Yeah. Um, all right. Well, before we get into questions here in a second, just want to jump into a couple tips here for lead, just briefly, and then we'll get into those questions. And so one thing to so I have confirmation from GBCI that you can use version 2 if you like it, or version 1 you can still use it, and no updates as to whether version 1 will retire. And so I'm talking about the EPA outdoor water budget. So you can use either one, whichever one you prefer. One thing you should know about the old one is that if you have a mixed irrigation, so you've got half of your site being irrigated and the other half not. Like maybe you're irrigating the turf, but not irrigating the native plants, right? You must then produce two different reports, two different water budgets, and then I believe average them together. It's a little bit quirky. And part of the reason for that is if you understand or familiar with the old water budget tool, you will see there is a question on it that asks whether the site is irrigated or not. And you will notice if you've got this new version downloaded that that question does not exist. So while we were doing this webinar, I actually emailed USGBC back to say, look, under this new one, it's smart, right? It allows you to mix and match irrigated and non-irrigated sites. Are you really going to make people do two of these now? Can they just do one? So again, I won't get that response for a long time, but we'll make sure to get that out to all of our lead readers, lead partners as an update on that. Now, the other thing you want to think about is a project we're actually working on right now. So I want to kind of get into the multifamily case study here real quick. And and this could actually happen with multifamily or probably a large single family development. But let's say you have a wetland in the area and you want to preserve that wetland. And so in order to do that, you are extending the scope of the lead project boundary to the wetland to include it. Well, we have ruling from GBCI here in this case as well that you can use the wetland in your water savings. And of course, nobody is going to irrigate a wetland. So it's a zero water. It's going to boost your water savings astronomically by incorporating the wetland into it. But there's are always trade-offs. We talk about if you're in our um, certified green home professional training, we always talk about trade-offs, right? And so the trade-off here is with compact development. And so this is under location and transportation. So if you expand the lead boundary in your plans and you're doing a multifamily, especially, or a single family development, your your acreage will increase, thus reducing your units per dwelling acre, your dwelling units per dwelling acre, and thus you could potentially lose points here by doing that. And so it's a trade-off to expand the lead boundary to include the wetland, which brings in a whole other host of benefits from stormwater mitigation to heat island effect to water reduction, but it harms your compact development because then you have less units on a larger acre. So that's the kind of trade-off you have to consider. So for this particular project we're working on, this is if you go into the lead workbook and you go into the water performance calculator tool. This particular project we have has Energy Star clothes washers and dishwashers, 1 gallon per flush toilets, 1.2 sink aerators, 1.5 gallon per minute kitchen aerators, 1.75 shower heads, and will be tested in the end to verify that there are no water leaks. So you can see the results of what the design says it should be versus, of the devices versus the baseline and what they're saving indoor. And then with the outdoor water budget savings we use, you can see our outdoor savings, including the wetland, and then that gives us a total of nearly 80% from baseline in water savings. So here's what it looks like in the new version 2 outdoor water calculator. I actually didn't realize before this session I could name each of these things, so they don't really say what they are anymore, as detailed as the old one did, but I like the naming feature. That's very cool, and I didn't realize that. I thought it was a locked cell. So these are essentially just trees and shrubs, and some of this is turf grass. This cool season turf, of course, up north in northern Michigan. And then this is our wetland here, which again, I realized I could name that over there. I didn't have to do this, but I didn't know that putting it together until after the training. Um, and so, this is a 60,000 square foot development with the vast majority of the landscape going into the wetland. So you can just see how much of an impact the wetland is making on this multifamily property. So you can see here, the other thing I want to point out here, these are our results, of course. This is our baseline, 120,000. And then this is our design landscape, which is 0 because none of it's irrigated. Now, um, as you will see in the LEAD program, you have to use your results are something called LWR, Landscape Water Requirements. And so if you're familiar with LEAD and you're not new to it and you're looking at this new version of WaterSense, you're going to be like, wait a minute, there's no landscape water requirement. What do I do? I'm panicking. I can't use it. No. So this is that right here. This on that third tab, the summary tab, the outdoor water use, water efficient landscape design. That is going to be your new LWR landscape water requirement. So again, here you can see it's 0 because we have no irrigation on the site at all. So it is 0 water irrigation for the site. And so you can see right here, this is the workbook, the LEAD workbook that sits above the indoor water use data. And so this is our baseline, 120, 120 there. And then this is our landscape water requirement. Again, matching the 0 here with the outdoor site. And so what this does in the workbook, if you head over to the water efficiency tab, you'll see it populates a 76% water savings. That's 12 points. But if you go over, I believe it's 75% or so, you can actually get an innovation credit here. Here it is, exemplary performance. If you go over 70%. So I had to go over to the innovation and I picked up another point. So that's 13 points right out the gate in this project we're working on. Now, one thing I want to notice, if I remove that 4,000 square feet of wetland, the water savings drop by 61%, and that ends up being a 2-point loss. This goes down to 11 and we lose this because we fall below the 70%. And we would then actually gain a point by shrinking the LEAD boundary under the compact development. So we lose 2 in water, gain 1 in the other one. And so you can see here in this case, it's marginal, it's 1 point, and I've seen others, swing other directions, but it behooves us to include the wetland as opposed to try to getting the compact development with LEAD. Now let's take a quick look at our Green Star Home certification. If you're using our Green Star Home certification program, the first thing you want to do in the workbook is make sure you drop in the number of bedrooms. That's going to power your home water score. And then if you tab over to the home water score, you will see I input the data for that same multifamily case study we just talked about. I input what the flow rates are in each of the indoor water use. And then I believe for Green Star, we're going to end up we're not going to do what LEAD does, which is the peak. We're going to do the total water use to be more accurate in our water use. So you would put the total water use over here, and then you would put that here. But you can already see there's a glitch if you know our home water score program. Number one, our home water score doesn't go above 10. So it's already glitched out. And second, we're not going to allow 0. We're going to actually probably require that you have to consider hand watering in many cases. So we actually, now that this new tool doesn't consider that like the old tool used to do, we have to go back to our technical committee and determine how we're going to handle that. But for now, that just gives you an example of how this gets inserted into our Green Star workbook. So, before we get into those questions, just a reminder that yes, this session is being recorded and we will post it up on our YouTube channel. You can go there in the next week to find it, or you can go there now, click subscribe, and get an instant update. For those of you watching this in the future on demand, get your quiz, take your quiz with an 80% passing rate to receive your CUs. For those of you here live today, go and get your Gutenberg cert, which will be sent to you, or you can find it in your account as long as you've been here for the entire CU hour. And as always, a huge thanks to our board of directors, our volunteers, our executive director, Jose, Reina, all of our members. We have almost 500. We're trying to hit 500 here by the end of the quarter. So we hope if you haven't become a member, huge thanks to all of our sponsors who are allowing us to meet these sustainability goals and beat them by providing services and products that will get you there. So, questions that we have for the speaker. Um, I guess I'll throw one in, and I think that is that would you have any sense if someone is trying to figure out, look, I didn't select irrigation, I didn't want to pay for irrigation. I wanted to be more sustainable. Sometimes we find irrigation it needs commissioning, it ends up leaking, it, causes more problems than it might be worth. So, but someone still probably has to hand water when there's a drought. So would there be any way to kind of use this tool to sort of figure out what that might be?
You could potentially look at what an irrigation system would apply, or even what your baseline water use needs are,
Mhm.
and potentially make some type of assumption surrounding that on what you may hand water. Um, I don't have an exact calculation that I would recommend, but
Mhm.
this can kind of predict your theoretical water needs for that landscape. So that's what I would say.
Well, anything to add to that, Sarah?
Oh yeah, I agree with Holly. The
Yeah.
tool's not designed, to predict that.
Yeah.
But yeah, just based on what, the tool produces for your baseline, you could maybe make some assumptions for yourself.
Okay. I know, like, the obviously spray, right? It's spraying everywhere. Typically, that's how you hand water, right? You get a spray out and you're just spraying everywhere. It's going all directions. So did that come kind of close to what that might be? Or is even that still more efficient than someone going around with a handheld?
I don't think we have any data to support that those are similar.
Yeah.
So
Yeah,
yeah,
you
I
you
couldn't
need
give
you
you a
need a
straight
lot of
answer.
assumptions. How
Yeah.
frequently are they going out there? What type are they using a sprinkler? Are they using just, a spray from a hose? There's just a
Yeah.
lot of
And
assumptions that we wouldn't have to really be able to get at that.
yeah,
Yeah.
and what makes spray efficient often is our assumption that it waters everything evenly, which a hand watering definitely is not the case. So I would say that that's probably like the main difference, is how it's distributed in the landscape.
Well, that's a good point because I see spray and I always joke, I always see people's sprays spraying the roads, spraying the sidewalks, and I'm like, I hope, I wonder if that will help the sidewalk or the side of your house grow better. I don't know, but I ask those questions to people. So you just said, but spray is more efficient. So would your tool
I'm not saying
assume,
it's more efficient. I'm just saying that's how we measure efficiency for spray, I guess.
right?
Yeah.
Yeah,
So
but
is
I
your
mean, if someone's
tool,
just like carrying like a watering can around, I think you can assume that it's probably not evenly distributing in the landscape.
yeah,
And if
and
we're
I'm,
wandering sidewalk, that's just bad design and maintenance.
what,
I agree with you.
yeah, so I want to set aside the hand watering thing for a second. I want to confuse the two. What I mean to say is you said you assumed spray is just covering the area that it needs to. So
Yeah.
let me ask you this question. So your tool is assuming that, or would you need that landscape professional really to design it properly?
I mean, we are assuming that I mean, yeah, I don't know. I guess I don't know how to tackle that. Yeah, we do assume that, and we know that there are outliers. There are
Mhm.
landscape irrigation systems that are poorly designed,
Mhm.
and definitely to ensure that one is designed well is to hire a certified pro.
Oh, okay.
And that's where
And
you
The,
see some of those water savings in
yeah,
the tool when you like select that. So we do have kind
right.
of like a baseline if you don't use a certified pro.
Yeah.
Um, but yeah, I don't know
Okay.
if that
so the
answers your
tool is
question. That answers
assuming
your
us
question. Yeah.
that spray and rotor is 71% efficient, and then drip
Right.
irrigation is 90% efficient. So spray is
Right.
not the most efficient.
Right.
Um,
There's still
but
a lot to,
yeah,
yeah.
I'll just do another plug for the pros. We do have pros certified in irrigation audit, and that needs to be done at a regular interval. Sprays can get knocked out. They weren't initially installed to spray the road, but somebody
Mhm.
kicked it and there it is, or there's a leak or something that your system really needs to be checked on, and those certified pros can help with that.
Yeah. And then just real quick, any gray water or rainwater considerations in this, or is that not tied in?
No, it's not tied in. I mean, you could, yeah, you would need to assume or make some calculations on how much rainwater you're capturing, and then maybe you could subtract that out from your total needs.
Right.
But yeah, it's not necessarily giving you credit for that. This is just telling you what should be or could be or likely will be applied to your landscape, no matter what the water source is. I think Brett maybe froze, or is it me?
No, I think
It's
it's
Brett.
Brett.
Okay.
Am I
Um,
frozen? You can't hear me?
yeah, you're back. You're
We can
back.
hear you now.
Oh,
Yep.
Yeah.
Yeah,
I
you
just
froze
turned
for a
this.
minute.
Yeah. Well, I know we're at the end, so I just wanted to quick, I guess, well, thank you. And where can people go to learn more?
Yeah, so our website is there, our contact information is there. Folks are definitely welcome to contact us. I actually missed a slide that's right before this, Brett. If you'll click over to that really quick. Um, it's the
Oh,
one.
no, I don't have that one. Sorry.
Oh, you don't? Okay, shoot.
No, no.
No,
Um,
it's all good.
it has, I don't know if you send out the slide deck here. I'll
Yeah,
quickly
yeah.
share my screen because I have it up. But this gives a bunch of other resources that we have. The water budget tool is out there. It's in the slides, the link, but we have several other outdoor resources folks can go for more information. Our Find a Pro tool, we talked a lot about that today. Product search can help you find irrigation controllers and spray sprinkler bodies that are labeled. We have some landscaping guides and information and some micro irrigation guides and tons more on the website. So
Yeah.
Yeah.
I have never
And I
heard of
will,
micro irrigation, so maybe we'll have to have
it's a
someone back to
fancy,
talk about
fancy,
that.
fancy word for drip, really.
Okay.
But
Okay.
yeah,
Well,
yeah.
it
Yeah.
sounds a lot cooler, so
yeah, right.
yeah,
Yeah.
yeah.
Yeah. And I will just add if you are poking around our website and you see any holes or any gaps, definitely let us know. We're always wanting to put out resources that are useful. So
Yeah.
let us know.
All right. Sarah Lavoie, Holly Can, thank you so much for educating us. And the rest of you, we will catch you next week. So take care and be well. Goodbye.
Yeah, thanks. Bye, everybody.
Thank you.
Be sure to check out all of our courses available online that you can watch anytime and anywhere to pick up your CEUs. Before you go, make sure to subscribe to us on YouTube to get weekly updates and stay up to date on green building science courses, webinars, and home tours. Thanks again.